So let's look up at this. So now it says, assume the population was 514 in 2010, write a function that determines the population of deer with respect to the years since 2010. So we have to define some variables here. So we say T is our number of years since 2010. And I'll say P is the population of deer. And I know I have the reference point that in 2010, which is 0 years since 2010, I had 514 deer. So that means that my population, I start at 514 and I multiply by my 1 unit change factor, 1.0473 T times. So if I was looking for the year 2011, oh, what did I just do? I just made a mistake, didn't I? Because 514 was in the year 2010, but my T is supposed to be in the year since 2000. Haha, you have to be very careful when you are reading the problems, but not only that, when you're defining your variables. So T is not the number of years since 2010. T is the number of years since 2000. So that means then it's not year 0 that I have 514 deer. It's year 10 that I have 514 deer. Very important that we pay attention to how the variable is defined because it changes your reference point. So since my reference point is not the vertical intercept, I have to account by that by saying T minus 10. Because if I wanted to find out what was the population of deer in the year 2011, I would take what I had in 2010 and just multiply it by that 1 year change factor just once. All right. So let's go on. Let's rewrite this function using the 15-year factor. Well, the 15-year factor, what did we say the 15-year factor was? Remember, the 15-year change factor, if you look over here, was 2. 2 is our 15-year change factor. So if I rewrite it with that, I get P equals, I've got the same reference point, so the output part's not changing. It's this part here that's changing. I'm going to use 2 because that's my 15-year change factor. But if I use 2, I know I have to account for the fact that that's the 15-year change factor by raising it to the 1/15th power, because I still need the result to be the same. These two equations have to give me the same result. When I'm asking for the population of deer in 2020, I need to be able to get the same result no matter which equation I use. So I have to compensate for the fact that I'm using the 15-year change factor by raising the value of that 15-year change factor to the 1/15th power. Now, this can be rewritten like this. This is a more common way to see it, where using rules of exponents, we write it as t minus 10 over 15. The 10 is the reference input. The 15 is because I'm using a 15-year change factor. Okay, so I have to account for that. So how many deer will there be in 2015? Well, in other words, we're looking for, in 2015 is 15 years after 2000. So I'm looking for P of 15. So I take my equation. It doesn't matter which one I take. They better give me the same answer. And when I plug that in to Desmos, I should get something like 647.6. So approximately 648 deer. And then it said, in what year will the population be 1001? So in other words, if my population is 1001, how many years went by from the year 2000? Now, we don't have a way to solve this yet algebraically. That's coming up in the next unit. So instead, we're going to solve, and we find out that it's 24, t would be 24.423. So over here, if we get t equals 24.423, that means it's in the year 2024. All right, hopefully that's helpful to you. There's one really important thing I want to point out here, and that was when I was up here. Notice how if I would have defined my variable differently, I would have had a different reference point. So if I would have said something like, get a new piece of paper here somehow, if I would have said that I want t to be the number of years since 2010, like I had originally started, then my formula would be P at t equals 514, 1.0473, all right? And in this case, my reference point, because I know that in 2010 I had 514 deer, my reference point would be this 514. And so all I would have here is a t, because it would be really t minus 0, and the minus 0 I don't need to say. So in 2011, that would be just 1 year later. What if I changed my t value again? What if I said t was defined as the number of years since 2020? Now my reference point, right, since I know in 2010 I have 514 deer, my reference point here is, if t is the number of years since 2020, 10 years before that, my reference point is negative 10, 514. So when I go to write my formula now, I would have 514, 1.0473 raised to the power of t minus negative 10. Or I could say P of t is 514, 1.0473 t plus 10. So we have to be careful how we're defining our variables, because every time we define a variable, that affects what my reference point is. And that effect on my reference point has a major effect on how I write my formula. Okay, if you have any questions, shoot me an email. I'd be happy to go over any of this again, and have a great day.